start with next concept, that is second order derivatives. So here is, let y is equal to some function, that is f of x. Then I differentiate this function as nothing but dy by dx, which is equal to, I can write this as f dash of x, and I will call this as equation 1. If f dash of x is a differentiable, okay, again we can differentiate this one with respect to x, and this becomes dy by dx of dy by dx, and this will be of f double dash of x, I can say, and we can write this as d square y by dx square, and we'll call it this as second order derivative. Hope this is clear. I take a function y, and this is a function of x variable. I differentiate this function with respect to x, and this becomes dy by dx is equal to f dash of x. I can say that if this f dash of x is a differentiable again, then you can differentiate this as nothing but d by dx of dy by dx, which is equal to f double dash of x. We can write this as d square y by dx square, and we'll call it this is a second order derivative. Is nothing but the degree of this derivative is 2. We can call it this is a second order derivative. And this second order derivative we can also denote it as caps d square y or y double dash or y2. So second order derivative we can also denote it in these 3 ways. Is it clear? So we just go with some examples. Example is, find d square y by dx square and function is y is equal to, if y is equal to x cube plus tan x. Okay, we need to find d square y by dx square. The function is y and it is like a f of x, means both the function is in the variable x. You need to differentiate this function twice. It's nothing but, consider the function y is equal to x cube plus tan x. Differentiate this function with respect to variable x is there, so you have to differentiate this with respect to x. It's nothing but dy by dx. So now these two are like sum of two functions. You can differentiate both the functions separately. So x cube derivative is 3x square plus tan x derivative is secant square x. This is what the derivative of this function. Okay, once we can differentiate this again, right? This function we can differentiate it again. So that is what we need it. That is d square y by dx square. Differentiate again with respect to x. Okay, this is nothing but this will be d by dx. Differentiate with respect to x of this dy by dx. Again, both are sum of two functions. You can differentiate both the terms separately. So this is 3 is a constant, keep it as it is. Derivative of x square is 2x plus secant square derivative is, this power will comes as a product, and this is a secant x. Again, A derivative of a secant is secant x into tan x. Hope you understood this. Now this is d square y by dx square is equal to 3 into 2 is 6x plus 2 into secant x into secant x is secant square x into tan x. This is what the required second order derivative for this function. Hope this is understood. Okay. So we just move on to the next example. Question is, if y is a sin x plus b cos x, the question is, prove that d square y by dx square plus y is equal to 0. Here is function y is a sin x plus b cos x. We need to prove this as d square y by dx square plus y is equal to 0. Given function plus you have to differentiate this twice, that derivative function. If you added both, you should get it 0. So that is what we need to prove. Differentiate this with respect to x, that is dy by dx, which is equal to a is a constant, sin x derivative is cos x plus b, cos x derivative is minus sin x. So I'll just write it directly, that is minus b sin x. Clear? Again I differentiate this. Differentiate again with respect to x is nothing but d square y by dx square is equal to cos x derivative is minus sin x. So I'll write it directly minus a sin x minus b sin x derivative is cos x. We need to prove d square y by dx square plus y is equal to 0 and just consider only the LHS, and we need to prove that is equal to 0, that is what RHS. Let d square y by dx square plus y, and this is equal to d square y by dx square is this minus a sin x minus b cos x. These two terms is for d square y by dx plus y, given function y is nothing but a sin x plus b cos x. A sin x plus b cos x. Now minus a sin x plus a sin x, the same term with opposite sign, just cancel out those two. Next, minus b cos x plus b cos x, again the same term but opposite sign, cancel out. All the four terms got cancelled, therefore the remaining is 0, and this is what the required proof. Okay. Next one is and from this concept you can expect 5-mark question, and it is a compulsory from this concept. Second order derivative. Let's go with the example next. If y is equal to 3 times e power 2x plus 2 times e power 3x, prove that d square y by dx square minus 5 into dy by dx xy is equal to 0. To prove this one, that is equal to 0, we need second order derivative of this, first order derivative of this, again the given function. Okay, here is y is equal to 3 times e power 2x plus 2 times e power 3x. Differentiate this with respect to x is nothing but dy by dx is equal to 3 into, as I said that exponential derivative is, whatever the exponential you just write as it is e power 2x. Next what you will do is, you need to differentiate the power of this e. So e power is 2x is there, 2x derivative is 2 it is, clear, plus 2 into, again exponential derivative is the same function, you just write it. Once you write the same exponential function, after that you have to differentiate the power of a e is nothing but 3x derivative is a 3. Is it clear? I will just write directly, that is 2 into 3 is a 6. 6 times e power 2x plus again 6 times e power 3x. Clear? Again differentiate this with respect to x, you will get the second order derivative. Clear? That is d square y by dx square is nothing but, keep it the 6 as it is, derivative of the exponential, you just write the first exponential function as it is. Once you differentiate this 2x, again you will get it 2 only, plus 6 into e power 3x, again derivative of the 3x is a 3. Okay, now 3 into 2, sorry 6 into 2 is 12, e power 2x, plus 6 into 3 is 18, e power 3x. This is what the second order. Now to prove this one, just consider the LHS, and at the last you need to prove RHS is a 0. So for that, I will consider the LHS d square y by dx square minus 5 into dy by dx plus 6y. You need to prove this is equal to 0. D square y by dx square, we got it as 12 e power 2x plus 18 e power 3x. This is for second order derivative, minus 5 into dy by dx. First order derivative, we got it as a 6 e power 2x plus 6 e power 3x. Clear? Next, plus 6 is their constant, 6, and y is the given function, y is nothing but 3 e power 2x plus 2 e power 3x. You simplify this, 12 e power 2x plus 18 e power 3x. What you will do now is, for these two terms, you just multiply with minus 5. Minus 5 into 6 is minus 30 e power 2x plus into minus minus 6 into 5 is again 30 e power 3x. The same way, you just multiply for these two terms by 6 is nothing but 6 into 3 is 18 e power 2x plus 6 into 2 is a 12 e power 3x. Is it clear? Now e power 2x, coefficient 12 is there. Again this one. Then e power 2x, coefficient minus 30 is there. Plus 12 minus 30, you will get minus 18. Clear? But here plus 18 is there. If you add it, plus 12 minus 30 and plus 18, all the three get cancelled. Is it clear? Cancel, cancel, cancel. So next is plus 18 minus 30 e power 3x is nothing but minus 12. Minus 12 e power 3x and plus 12 e power 3x. Again these two get cancelled. If all the terms terms get cancelled, you can write it that as 0, and this is what the required proof for this problem. Hope you guys understood this. Okay, so from this you can expect 5-mark question. Okay, so those problems we'll do it in the next class. Clear? Thank you guys.